Welcome. My name is Christian Seth Rabuya, and I'll be discussing with you these few topics. Companies commonly use the net present value and internal rate of return techniques to better understand the feasibility of projects. Each technique has different assumptions, including the assumption regarding the reinvestment rate. NPV does not have a reinvestment rate assumption, while IRR does. For IRR, the reinvestment rate assumption may change the outcome of the IRR. To begin with, reinvestment rate assumptions. The two tools have different reinvestment rate assumptions. The NPV has no reinvestment rate assumption. Therefore, the reinvestment rate will not change the outcome of the project. The IRR, or the internal rate of return, has a reinvestment rate assumption that assumes that the company will reinvest cash inflows at the IRR's rate of return for the lifetime of the project. If this reinvestment rate is too high to be feasible, then the IRR of the project will fall. If the reinvestment rate is higher than the IRR's rate of return, then the IRR of the project is feasible. For the considerations, NPV is a more useful technique, but also more complicated with more inputs and assumptions. It is also a better tool for comparing different projects at different time zones. The IRR technique is quicker for a company to calculate. The company can also adjust IRR for risk in two different ways. Either the company can risk adjust cash flows, or they adjust the IRR after calculation for a risk premium. Next, we'll be discussing the modified internal rate of return. The modified internal rate of return, commonly denoted as MIRR, is a financial measure that helps to determine the attractiveness of an investment and that can be used to compare different investments. Essentially, the modified internal rate of return is a modification of the internal rate of return, which resolves some issues associated with that financial measure. Now, the MIRR is primarily used in capital budgeting to identify the viability of an investment project. For instance, if the MIRR of a project is higher than its expected return, an investment is considered to be attractive. So we have the formula for how to calculate for the MIRR. We consider three key variables. First is the future value of positive cash flows discounted at the reinvestment rate. Second, the present value of negative cash flows discounted at the financing rate. And lastly, the number of periods being used. So generally, the manual calculation of MIRR is a tedious process that is prone to making mistakes. Alternatively, the MIRR can be easily calculated in spreadsheet applications such as Microsoft Excel. So for MIRR versus IRR, the modified internal rate of return, and it is a MIR provides a more realistic picture of the return on the investment project relative to the standard IRR. So the MIRR is commonly lower than the internal rate of return. So we'll proceed to net present value profiles. Net present value profile shows how the NPV changes in response to changing cost of capital. the point at which the NPV curve intersects the y-axis, it is the internal rate of return of the project, and where the NPV profiles of any two projects are plotted together, they're considered as called the crossover rate. So to further understand on the NPV profiles, we will give this example. Let's say you have a project that requires initial investment of $10 million and will generate net cash flows of $3.5 million in each of the next 5 years. If we want to see how sensitive the project's net present value is to the discount rate, we need to find the NPV values for the different discount rates, say 4%, 8%, 12%, 16%, and 20%. So NPV of the project at 4% discount rate can be determined as followed. So we have a 3.5 million times 1 minus the bracket of 1 plus 4% raised to the negative 5 over 4% minus the $10 million. So we have a result of 5,581,378. Then these are the values of the remaining discount rate of 8%, 12%, 16%, and so on and so forth. Let's say we have another project requiring initial investment of $5 million and generating cash flows of $2 million, $2.5 million, and $3 million in each of the next respective 3 years respectively. The NPV of the second project at 4% would be, let's say, $1.9 million. It's just a assumption. But from the calculations given, it gives a result of 3.2 million, so which is much higher than the assumed value. So on this table, it shows the NPV of the second project at different discount rates. So let's say from 24%, we have an 802,927. So if we plot the NPV profiles of both the projects, we can find their crossover rate here on where they intersect. So the discount rate at which an investor is indifferent between both the project because their NPVs are equal. So thank you for watching this video.